lesson 5-6. And this is one of those lessons that is really applicable. It's kind of ironic it falls at this time of year when it's one of the busiest shopping seasons of the year. Not to my, I don't really care for the busy shopping season, trust me. But nonetheless, it's a time of year, and this is an idea that is really applicable. Okay, you guys are going to be soon having jobs, if you don't already, and you'll be old enough to legally have an income. And so one of the things that you'll have to be able to decide for yourselves is what's a good deal and what's not, so you get the most for your money. All right. So this idea in this lesson is called markups and discounts. And we'll use this idea a fair amount in your own lives. Markup and discount. Okay. So there are really two different ideas here. One, you're going to make something more expensive. So that's what we call a markup. And two, you're going to make something cheaper by discounting it. Okay? Take a look at your book. What page, Drake? 235. Okay? So what is the actual definition of a markup? Austin, go ahead and read it for us.
Markup is the amount of increase in price.
Yep, okay, so we're talking about the amount of increase. Okay, and there's something called a selling price. And then if we switch over to page 235, okay, Connor, go ahead and read for us, what is a discount?
The amount by which the price of an item on sale is reduced is called a discount.
Right, okay, it's called a discount. Okay, so these both stem from this idea of percent of change. Okay, percent of change. Now, this is where this idea of the percent of change equation comes into play. If you recall, all right, we were looking at how things changed in the previous lesson, and I was having you look at kind of figuring out whether they changed by a positive amount or a negative amount. Well, the positive amount, an increase, would be a markup, and a negative amount would be a discount. Okay? Yeah.
And you said that no matter what, the increase is going to be above 100% and the decrease is below.
Right. So I said markups usually always have some kind of greater than 100% increase. Discounts are always going to be less than that 100% or that amount, that starting amount. So we might have only 80% of the original amount, a 20% decrease. That'd be like a 20% off. Okay. So let's go ahead and look at the two equations they give us here for percent markup and percent of discount. Okay. The percent of markup is going to equal the markup price, or how much it's been marked up over what? Chloe, what is it over? It's right there in the book. So we have the markup over the what? Yeah, the store's cost. See, it does cost something for stores to stock an item, buy that item. Okay, for instance, Meijer. Meijer has to purchase everything that's in its store. Then it sells it to you at a higher price in order to make a profit. Okay? So they'll get it from the wholesaler, that's what they're called, or the producer, or the people who make an item. This might be Nestle, made here in Indiana, by the way. It might be not GM, because they make cars, and Meijer doesn't sell cars. But it might be Nestle, it might be Hershey's, it might be some major organization, and then they mark it up. Okay? And that markup is based on, who do they have to pay to stock the shelves? They have to have lights and electricity, refrigeration units. So their costs play into this as well. Okay? So markup and stores cost. Okay? Now, what do you think the discount equation looks like? Yeah. Okay, so there's definitely going to be something to it. So the percent of discount is going to equal the discount over what? What's it say in our book there? Caleb? On the right, on 235 there. The discount over the what? Yeah, the regular price. Mary.
That says the store's cost. Does that mean like how much the store, like the electricity and stuff, or does it mean like the original
The
price?
original item of the original price that they had to pay for an item. So I'll give you an example of this. Um, let's say that a store has to buy a block of cheese. I buy blocks of cheese. I love cheese and crackers, one of my favorite snacks. Okay, so a store has to buy a block of cheese. Okay, for the store, like Meijer, every block of cheese might cost them $1.20. Okay, because the people who make the cheese still have to feed the animals that produce the milk that have to go into making the cheese. There's storage, and they have to pay the people that, churn it all up and wrap it and all that business. So store's cost might be $1.20. Okay, so let's go ahead and zoom in here. $1.20. Okay, now the Meijer determines that they need to basically mark this item up $1. Okay, so they would add, so they're going to sell it for $2.20. So they add to it, the markup is $1. Okay, do you see where I'm going with this? The actual price of the cheese for us, the customer in the store, would be $2.20. But what we're trying to determine here is what is the percent markup? Okay, by how much did they increase the price over what they had to pay for it? All right, so can we do this? Is this a pretty easy division problem? Yeah, it is. And so let's go ahead and do this division problem. Do you have it as a decimal? Okay, what's up?
I was just gonna say, so basically the store's cost is just their regular price.
No. The store's cost is what they pay. We never see that price. Okay, so what happens is Meijer sends a representative to a giant dairy farm with lots of cows. And they say, we will buy your milk for 50 cents a gallon. Then they bring it into the store and they sell it for $3 a gallon. Okay, that's the price we pay. The markup would be from 50 cents to $3, or $2.50. That's the markup. Okay, so the markup is what they do to make a profit. So let me even label this because I think that might be beneficial here. This is what the store pays for an item. This is how much more they charge. We would pay $2.20. Okay? But that's not necessarily what we're asking for. What we're asking for is what is the percent markup? By how much is Meijer marking up the price? Okay, and in this particular case, we would take the 1 and we would divide it by the 1.2. What do we get as a decimal there? Yeah. Okay, so it'd be 0.83 repeating. If we were to convert that into a percent by multiplying by 100 or moving the decimal 2 places, not 3, oh my goodness, not 1, oh man, but 2 places, what would be the actual percent here? Yeah, 83%. So we would say, let me change the color here, that there is an 83% markup on that item. Okay, there's an 83% markup on that block of cheese. So Meijer buys the cheese from the dairy provider. They mark it up 83%. They put it on their shelf. You pay $2.20. Meijer pockets $1. Okay. If you have a lot of cheese, yeah. So if you go to the store and you see 700 blocks of cheese, well, there's $700 of potential profit.
If 1 million people buy 1 block of cheese.
Yeah, it's $1 million. Absolutely.
Or you just steal the cheese.
Oh, well, we're not in the habit of breaking the law. We're going to omit that person from this conversation. Just making that note here in the recording. All right. Now, the discounted price. This is probably what is easier for you to understand since this is more applicable. If you are a store owner, this markup is very important. Okay, if you're a store owner, you have to know how to mark up your prices to make a profit. Okay, you may have seen this. If you ever walked into a small store and you wanted to buy a bottle of pop, pop is usually more expensive by the bottle in a small store versus a big store. Okay, all of the stores have to buy the pop, and then they mark it up to make a profit. We do that here with our concession stand. We do. We buy cases of pop, and then we sell each can of pop for $1. In real life, those cans of pop are probably only about 25 cents. We make about 75 cents per can of pop, and then that money goes to Mr. Collins, and he's able to buy jerseys and equipment and things like that for the sports program. So even our own concession stand, we mark up everything to make a profit. That's what we do. Okay? Now, discounted price. How much something has been discounted. Let's say that you need a new pair of shoes. Okay? And normally these shoes have a regular price. Let me go ahead and pick a different color here. They have a regular price of $99. Hey, you know what? I never buy shoes. Let's not, oh my gosh. $99 for a new pair of kicks. Okay? So now what we have to decide is, now they're going to be discounted. Okay? They're going to be discounted by, let's say, 20 bucks. So if you look in your book at some of these examples, okay, they want you to be able to use this equation to your benefit. All right, and if you see some of their examples in there, okay, when they're looking for a discount, a percent discount, they're basically trying to figure out how much of the original amount is discounted. Okay, so what we're going to do is we're going to say it's been marked down $20. That's the discount. So I'm going to put $20 up here in the top. Not necessarily the sales price, but how much it's been discounted. So if I had a $99 pair of shoes and it was $20 off, how much am I really going to pay for them? Before tax, of course. Yeah. Yeah, $79. Yeah, sure. We want to know how much of a discount is that. When we think of it in terms of percent, it kind of gives us a better idea if it's really a good deal or not. So we go ahead and we divide, like we've been doing. 20 divided by 99 is what decimal? 0.20 repeat. Okay. Ooh, nice repeating decimal. Oh, I like those. Okay. What percent is that really? Right around what? That's right around a 20% discount. So you probably wouldn't see $20 off. You would probably see a big sales sign that says, all shoes in this section, 20% off. Okay? It kind of makes sense. 99 is really close to what number? 100. 20 over 100 is really close to what percent? 20%. Okay? So this is how we look at discounts and markups. I'm going to have you try two problems on your own at your tables, okay? So here's some of the breakdown. I'm going to put them both up on here, and then you can go ahead and do them with the people around you. All right, let's say that, what's a good store? What's a good store? McDonald's? Chick-fil-A. We're not food, because they don't usually run 30% off Big Macs this week.
Yes.
No. All right, Foot Locker, Coach. Foot Locker is running a sale on Crocs. Absolutely. Yep. Crocs. They're the elite, shiny, glow-in-the-dark track running Crocs. Okay? It's a new special kind of brand. They weren't as popular as they had hoped for. So they have too many in stock, and they need to go ahead and now sell a bunch because at a discounted price to get rid of them. Okay? Hey, relax, yo. So Foot Locker is running a sale on Crocs, and here's what they have. They are originally $14.99. But they're on sale for $9.99. What is the percent discount? Okay, that's the first example. You can go ahead and begin on that one. I'll write the second example up here for our markup. Ace Hardware has bought some grills for they want to sell them for okay. So we have Foot Locker is running a sale, and Ace Hardware bought some grills for $75, and they want to sell them for $129.99. What is the percent markup? Okay. See if you can figure this out. See if you can find out what the discounted price on these Crocs is, or what's the percent discount, and what's the percent markup for Ace Hardware's grills that they bought. Okay, can someone walk me through what you would have done in the first problem? In the first problem. Okay, Drake.
You would find the regular price.
Okay, so I need to find the regular price. You know what? That's a great starting point. Let me write that down. Okay, so regular price is how much? Yep, $14.99. Okay, and what is my discount? Not the discounted price, but the discount. There's a difference. What is the discount? How much money am I actually saving? Yeah. $5? $5? What do you think? The 99s are kind of weird, aren't they? $14.99 minus $9.99 is $5. So the discount is $5. Okay, that's the discount. So now we set it up so that we can find the percent discount. basically what would the sales sign say? Okay, because stores are never going to tell you this much off, not usually. Okay, they sometimes do, but very rarely. So what would we put here? How are we going to find the percent discount? What number goes on top? What number goes on bottom, etc.? What do you think? Yeah, Bo? It is 5 over 14.99. And that works out to what decimal? It's going to be really close to 33, right? Yeah, 0.3333. Okay. Because this is really close to 15. 5 is 1/3 of 15. So this is roughly a 33% discount. If I were buying, okay, I would say 33%, 1/3 is a pretty good discount. So I would probably consider this a deal. Okay. Ace Hardware has bought some grills for $75 a piece. They want to sell them for $129.99. Okay. So how much did they pay for them? What is the store's cost here? How much did they have to put out of pocket to get these grills per grill? What did they have to pay? Colby? They had to pay $75. So when we're doing a percent markup problem, the store paid $75. Okay, the store paid. How much did they mark it up? Yeah. $54.99. So the markup was $54.99. So we want to figure out what percent did they mark it up? Okay, how much of a percentage was the markup? So to do this, we're saying we're going to find percent markup. Okay, and how would I go about solving this? What would I put where? Here. Erica, what am I going to do? I've obviously got to create a fraction. What's going to go on top? What's going to go on the bottom? Oh, yeah, that's right. $54.99 on top. Very good. And what's going to go on the bottom, Erica? 75. Okay, and when I do that, what do I get as a decimal? It's obviously going to be less than 1. It's going to be let me see if I can guess. Probably right around, what, 0.7-ish? What is it? 0.73, okay? So 0.73, which is roughly a 73% markup. Okay, 73% markup. Erica?
If you put like the original price they had and just divided it that way, you got the same answer.
Kind of. What do you mean?
Instead of 73%.
You would have got 173%, right? Okay. So yeah, here's another way we kind of looked at it, right? If I had done 129.99 over 75, I would have gotten 173%. And what we learned last week was that's really a positive 73% increase. See how it ties into what we've already learned? You see how it's really not any different. I'm trying to have you look at it a little in different ways, okay? Trying to have you explore different ways of looking at this. If that works for you, that's great, and I would encourage you to do that. If that makes more sense to you, as long as you can get to the point where you understand markup and discount, I'm cool with that, okay? I just wanted to show you this method. This is what stores do. All right, I need to now kind of reverse it for a little bit. I'll do one more example. I'll give you your homework. You probably won't have a whole lot of time in class today, but I wanted to make sure you've seen all these different examples, okay? So here's how this works. Let's say that a store like Meijer is going to mark up a product 210%, okay? So I'm not going to necessarily even write this out in a sentence, but I'm going to tell you I'm going to give you the percent markup right up front. The markup is 210%. The The markup is 210%. That's pretty significant. Now, I'm going to tell you that the price on the shelf, okay, so the price we would pay, the price on the shelf is $100. Is $100. Now, I want to know how much the store paid for the item. That's what I really want to know. So, before I get too far here, I'm going to go back and I'm going to start with this. My equation, percent of markup equals markup over store's cost. Okay? And we're going to decide whether or not we have enough information to figure this out. Okay? We're going to decide if we have enough information to figure this out. All right, so I'm going to actually copy that equation. And I'm going to go over, and I'm going to paste it, like so. Okay. I know what the percent of markup is, so in that way, I'm good. I've got it here and here. So I know that there's a 210%. Does price on the shelf fit into this equation? No. No, it doesn't. No, it doesn't. Okay? Markup does, but the store's cost does, store's paid, but price on the shelf doesn't. This equation doesn't give us price on the shelf. So if I had a problem like this, given this equation, could I solve it? No, I couldn't, and sometimes that happens. Now, let's say I changed price on a shelf to markup. No, I said price on the shelf. Markup and price on the shelf are two different things.
No, I mean markup under 210% and markup.
No, this is the markup percent. This is the markup price. You see how they're different? One is markup in money. One is markup in percent. They're two different things. I can have something that was marked up $5 and it could have been marked up 200%. I could have something that was marked up $5 and it might have only been marked up 10%. So the percents and the markup have two different categories. One's a percent, one's money. Now I can solve this, okay? My markup percent and my markup price are there. I can plug them into my equation. So when I plug it into the equation, I have to plug it in as a what? The percent, yeah.
The decimal.
I have to plug it in as a decimal. So here's how this works. This is going to be what decimal? 210% is 2.1. And that's going to equal 100 over x. How do I solve this? This is weird. How do I solve this? Yeah. I can't do divided by 100. I have to change the way it looks a little bit first. Because the real trick to this is we're going to have to cross multiply. But can I cross multiply it the way it's written? Yeah.
You do 2.1 over 1.
Oh, yeah. I can put it over 1. Yeah. All right, so cool. Now I'm going to cross multiply. Drake, 100 times 1.
100.
Okay, for a minute there I thought we were going in the wrong direction, but you were good, okay? So 100 times 1 is 100. This equals 2.1x. Now how do I get x by itself? Yes. Divide by 2.1. Okay. What's 100 divided by 2.1? 47.6.
6190476.
Okay. Ladies and gentlemen, The store paid $47.62 for this item. They marked it up $100 so that we would pay $147.62. And that was a markup of 210%. Okay? If you are having a hard time with this, the whole idea of markup is way more I would say difficult, not as natural for us to kind of think through as discount, because we're surrounded by discounts all the time. But unless you're a business owner or unless you're selling something, we don't really think in terms of marking up something. Okay? We're not, the retail market is never going to talk about this. They don't want you to know how much profit they're making on items. Okay? They're never going to talk about it. So this is how I wanted to show you a markup example. Anyone have any questions? Yeah, go ahead and ask your question. You don't understand what?
I don't understand like the markup and discount thing. Like how you know what to put.
You have to read it very carefully. So Grace Pennicamp, look at this equation here, okay? They're going to give you, always going to give you two pieces of information, right? Why? Why are they going to give you two? Yes? It's only one less than what I need. This equation has how many pieces of information in it? 3. So they're always going to give you two pieces of information. Grace, if I know two pieces of information, can I rearrange this equation to solve for the unknown? I can't. So if they give me markup and stores cost, I can solve percent of markup. The way you'll know is if there's a price, if they tell you it costs a certain amount, or if there's a percent. If it has a percent, it's definitely going to be on this side. If it has a price, you have to read carefully to determine whether it's the amount that they're marking up or discounting, or if it's the amount they paid out or you pay. So you have to read it very carefully. Money on this side, percent on the left. You have to read for the information very carefully. So if I were you and I was starting a problem, I would have this equation and the percent of discount equation at the very top of my paper so that I could reference it for every problem. They will always give you two pieces of information so that you can find the third, always. Okay. Ladies and gentlemen, your homework. Your question, by the way, was a very good one. That's a great question. And if you can figure out how to answer that question before you leave middle school, you will be very successful in high school. All right. Your homework is page 237. Numbers 1 through 4 all. And 6 through 18 the evens. Ladies and gentlemen, how many problems is this?
9.
Not many. That's the right answer. All right. Have a great day.